Our objective for today, I can simplify radical expressions. Read it together. 1, 2, 3. I can simplify radical expressions. We already covered some of these at the beginning of the year. I introduced them already. So we know most of what we're going to see today. The only thing that is different is the fact that I'm introducing now with polynomials. All right, so with that said, copy this down, please. Radical expressions, what are they? An expression that contains a radical sign. Radical expressions, an expression that contains a radical sign. Radical expressions, an expression that contains a radical sign. Examples: square root of 25, 8 times square root of x, square root of x squared plus 6x plus 9, and square root of x over 4 minus 6. So once again, radical expressions are expressions that contain a radical sign. Let me show you non-examples. Non-examples.
Wow.
Square root of x equals y. Y equals x plus square root of 16 and negative 3 plus x squared. Okay, some of the things that I want you to indicate there on your notes, I want you to underline the word radical, and this is so that you can remember the symbol, what it looks like. And I said when we got to simplifying radicals, I said this is now called the radical, which is, we used to know it as a square root, but we called it the radical because we had different indexes outside. Remember that?
Yeah.
We had an index of 3, of 4, and so on and so forth, right?
Yeah.
And whatever is inside of the radical, check this out, everybody look up, such as this one, this one, this one, and this one, are called the radicand. This is called the radicand, the radicand, the radicand, and the radicand. Notice that the negative 6 is not inside, it's outside. That's why that's not called the radicand. Only whatever's inside of the root. So make sure you write that down. So think about it. According to the definition, it says an expression that contains a radical sign. Let's see, do I have an expression? Yes. Does it have a radical sign? Yes. Same here, same here, same here. Think about it. Why are these non-examples? Don't say it out loud. Okay? Okay, whisper to your neighbor why these are non-examples. It has to be a what? So two things that it has to be an expression, and it has to contain a square root symbol or a radical. A square root symbol or a radical. The critical attributes is that a radical expression needs to be an expression and it needs to contain a square root or a radical. All right, copy these steps down, please. Step number 1, simplify. Step number 2, factor completely. Step number 3, identify the square root. Step number 4, write the radical expression in simplest form. What does that mean? And I put it in parentheses. That the radicand has no perfect square factors other than 1 or fractions, and no square roots in the denominator. Copy that, please. Okay, here we go. Steps. Number 1, we simplify. Simplify. Step 2, factor completely. Factor completely. Step 3, identify the square root. Step 4, we need to make sure we write it in simplest form. And what is that? Write the radical expression in simplest form by what? Make sure that the radicand has no perfect square factors other than 1 or fractions. So that means we cannot have fractions inside of the radical sign. Also, there are no square roots on the denominator of the expression. So when you have an expression, if there's a square root on the denominator, it's not simplified. Okay? All right, so with that said, check this out. Really quick, your attention, please. So we already covered on yesterday's lesson in regards to what kind of values we can substitute in here inside of the radical. We said we can substitute values from 0 all the way to the positive numbers. Is that correct? Why can't we substitute negative numbers? Because there are no real numbers, right? They're imaginary numbers. Are we there? Okay, so with that said, also, when we got to these, everybody look up, please. When we got to these kind of expressions, I remember that I told you, look at the index, and all you have to do is divide the exponent by the index. Remember that? So therefore, what is the index here, the invisible? It's a 2. So therefore, 2 divided by 2 is 1. That's why this is a exponent of 1. It's invisible also. Everybody see that? However, from now on, since we know that we cannot substitute any negative numbers in here, everybody look up, please, or you're going to miss it. Since we cannot substitute any negative numbers inside of the radical, now that we have variables like this, instead of writing it like this, we're going to write it with an absolute value. And let me show you why. Why do we write it like this? Because if I substitute any value inside of the absolute value, what do I get always? It's a positive. And what did we say needs to go in here? Positive. Does everybody understand that? Yes, right? We covered that yesterday. All right, so with that said, copy these down, please. Example 1, and just copy, simplify. A, square root of 2 over 50. B, square root of 8 squared plus 15 squared. And square root of C, C is square root of x squared minus 6x plus 9. Okay, here we go. All right, pens down, eyes up here. Here we go. Look at this one. I'm going to go through the steps. Step 1 was what, everyone? Simplify. So this becomes square root of 1 over 25. Step 2, factor completely. Let's see, this one's already factored. This one I can factor. It becomes 5 times 5. Do you guys see that it's 5 times 5? Or how can I write 5 times 5? 5 to the second power. Is that correct? So therefore, 1 over 5 squared. All right, so therefore, what is square root of 1? 1. And what happens to this squared with a square root? Okay. As you're copying this one, I'm going to do this one. Check this out. Simplify. Let's see. What is 8 squared? 64. What is 15 squared? 225. From there, we need to simplify this. This becomes square root of 289. And square root of 289, let's see. One number times itself gives me a number 9.
16.
3 or ending in 9. 7. So therefore this is 17. 17 times 17. Yeah, 7 times 7 is 49.
That's right.
So that's how you start finding your perfect square. So let's look at this one. That's fine. You can just factor completely. Here we go. Let's look at this one. C. Square root. We need to simplify. Is there a GCS? No. So then Power Rangers. 9, negative 6. So this is negative 3, negative 3. So we can write that as x minus 3 squared. Is that correct?
Yeah.
Because it's x minus 3 times x minus 3. And what happens to that exponent and the root? So therefore we're left with x minus 3 in absolute value because it has a variable. Right. Didn't I just, okay. You guys are smart. You just need to focus. What's that? Yes. So here we go. Any question with these? Okay, let's do some more practice. Here we go. Copy this down. Okay, copy these and do these by yourself. Example, this is, the other one was 1A, B, and C. Let's make this one example D. Oh. Example D and E. Be nice. Should be almost done.
That's what you did.
Okay, here we go. Square root. We need to simplify first. Let's see. 256 divided by 4. If it's in there, 6, 24, 1, 16. That's 4, 16. So this is 64. Square root of 64 is 8. Okay. This one, simplify. Square root of 49, which is what? 7. Thanks if you got that. Okay, good. Let's do one more practice one, and then we'll move on. Here we go. Copy this one down. Yes. So copy these ones. This is example F and example G. Do those by yourself, please. Okay, let's see. So step 1, we need to simplify, yes? So this becomes square root of 25 plus 144. What is square root of 25 plus 144? 169. So therefore this is 13. Because it ends in 9, so you need to look for a number that times itself gives us ending in 9. So it's only 3 or 7. So therefore it's not 17 because it was 289 for 17 times 17. So it has to be 13. Yes? Look at this one. This one with this cancel. We're left with 3 minus x with the absolute value symbol. Cancel, you got that by yourself? Okay? All right. So far so good, right? Yeah. So that's just simplifying. However, I'm going to introduce again. We already covered these when we multiplied and divided. And this is called the product property of square roots. And I already addressed that, like I said, at the beginning of the year, but only with numbers. Today I'm going to focus now using some polynomials. Okay? So here we go. So pay attention. So we're looking at two things, multiplication and division. Right now I'm going to cover product property, which is multiplication. Here we go. This is what it says. Pens down, eyes up here. You'll copy right after. So this is example 2A. This is how this goes. Step 1, we need to simplify. Can we simplify anymore? No. Step 2, factor completely. Can I factor this? Yes. Now, I showed you at the beginning of the year how to factor this using a factor tree. Remember that? However, for today, I want you to start thinking what number divides 24 that is a perfect squared number. Think about it. Very good thinking about it. So therefore, this could be 4 times 6. Is that correct? Is 4 a perfect square number? Yes. So the product property of roots is this, that you can rewrite this like this. Square root of 4 times square root of 6. So what is square root of 4? 2. Since this is not a perfect square, I just write it like this, and I'm done. Copy that, please. All right, so that was example 2A. Any questions with it? Okay, let's do another one. Here we go. I'll label this one right underneath 2Q. 2Q. Square root of 45. Don't say it out loud. Do that one by yourself, please. No way. Yeah, don't say it. All right, so if we think about it, factors of 45, one of them has to be a perfect square. I think the perfect square is 9 times 5. This becomes square root of 9 times square root of 5. Square root of 9 is 3, and I just bring down the square root of 5 next to it, and I'm done. Hands if you got that? Okay, so the last part, all I do is take the square root of the perfect squared number, which is 3, and when we write a number next to a root is multiplication. And that's it. Since we cannot find a perfect, a root without going into decimals. Is that correct for square root of 5? All right. So with that said, copy this next one down, please. Example 2B. Just write simplify and copy this down, please. And we need to use the same property. Here it goes. Let's do this one together. Square root of x cubed and y to the 4th. This becomes square root of x cubed times square root of y to the fourth. Is that correct? So, by looking at these, the only one that can be divided evenly by the index. What is the invisible index here? 2, and the invisible index here is 2. The only one that gives me an even number power is which one? Y. So what is 4 divided by 2? This becomes y to the second. Since this one cannot give me an even number, I just write it next to it. Square root of x cubed. And we're done. Copy that, please. Okay, let's move on to the next one. Okay, guys, really quick. Hold on. Now, check this out. Everybody look up, please. Look at this one. You're not paying attention. Can I rewrite this one, though? Let's see. Can I rewrite this as x to the second times x? Bring this down, okay? So what happens to this exponent? It crosses out, so therefore we're left with x times y squared, and what stays inside the square root? X. And if you don't see it, we can split this one up like this. X squared times square root of x, bring this down, and that's how we get this. Are we there? Okay. This is not completely simplified. That's why I missed a step, and that's why I'm showing it to you right now. So make sure when you get to this point, if you can find a factor for variables, so here it's x to the first times x to the second becomes x to the third. So therefore this becomes this, which becomes this. This will be the answer. Not this one. All right, so I'm going to stop right there, but I need you to get into the lesson and read a little bit into the quotient part. And it's simple. It's simple, guys. Like I said, we already saw it. So our homework for tonight is found on pages 708, numbers 1 through 23. Oh, have a good one, guys. Enjoy your homework. I'll see you guys tomorrow.